All right, so here we are. We're going to run spectrophotometry. So we have a Carry 60 uv-vis. There's our sample compartment. So I'll talk a little bit more about the instrument as we get going. All right, so here's our Agilent system. The first thing we want to do is go ahead and get a scan of the entire solution so we figure out which wavelengths are the most appropriate ones to use. So we're going to take our cuvette right here. Make sure that it is wiped down to the transparent sides. We don't want any funny business. So we're going to take this, and that goes down into our sample compartment. And we want to make sure that the window is aligned with the beam, which runs in this direction, so that we get a good absorbance signal. So close this up. And we're going to set up for a scan that runs from 800 nanometers down to 200 nanometers. We're actually going to go down to 350 because we don't need to go down into the UV. We know that we have a visible spectrum because we actually can see the color of the solution. And so we'll do a quick scan. Connect to the instrument real quick. It's basically what you hear is it's adjusting the monochromator so that it's actually aligning to the correct wavelength for starting. So we start at 800 nanometers. So it should scan it. The peak is at about 520 nanometers. So that's ideally what we'll want to use as our peak maximum for our analysis. Okay, so now since we've identified which wavelength we're going to use, we're now going to actually go into the calibration mode or concentration, use the concentration. So basically we go through a setup where we actually select our wavelength. I selected 520. The lab manual suggests 540. However, we just found our maximum right around 520, so that's the one I'm going to select. We're going to run 3 replicates and average them for each standard. So these are the standards. This is actually in milligrams per deciliter, and these are the dilutions based on how we actually made up the solutions in the cuvettes. So we have 5 standards and a blank. And then we'll actually run our check standard twice and see what we get. So we're all set up to run. So the first thing we need to do is put our blank in here. So I'm taking standard 6 out. We're going to replace it with our blank. So again, our blank just contains acid and water. So it should be nice and clean. Oops, we need to make sure we line the windows the correct way. That inside. And we want a 0. Load blank, which I just did. All right, so now we're actually going to be starting with our standards. Okay. I think that's our batch name. So we need standard 1. Retrieve standard 1. So you can actually see where it's reading down here. So now we're simply running all 6 standards, one after another, and recording to get a nice calibration curve. So as you can see, we are graphing absorbance versus the concentration, which gives us a linear curve. As expected, we're following Beer's law. We're using absorbance versus transmittance as was suggested by the manual because absorbance is linear. Alright, so then what we're going to do, since we don't have a cuvette with our standard in it, or with our sample in it, I'm going to take the blank cuvette pour that in waste. And we're going to take our check standard. Hopefully I can get down in there. Alright, so I got a full milliliter of our check standard. And I need to combine that with a milliliter of the iron nitrate solution so that we're going to form our colored complex. Must be getting a bubble. So you can see our solution has become colored because we have salicylate in there. Make sure everything's clean. And then we're going to read our check standard once, and then we're going to read it again. So let's take a look at the data analysis down here. And so what this is telling us is that our average is 0.72, but it's actually going to be twice that because we diluted the sample in half with the iron. I need to reset the, I wonder if I can do that. I just realized that with the standards, what we actually want to do is we want to put the concentration before dilution, which is 0.5. This should be 1.5. This should be 2.5. This should be 3.5. And this should be 5 deciliters, because if we do our dilutions right. So if I say OK, I wonder if it will recalculate. Okay, there we go. We recalculated based on that. Excellent. So you'll see now it's doubled the concentration, so it's 1.43, 1.44. It's what we expected, and it's actually milligrams per deciliter, not milligrams per liter. And of course we saw a really nice linear curve, which is excellent. So I'm going to print that report to a PDF. And I'll post that report on Blackboard for you guys to analyze as an example of an external calibration curve, which is used when you have clean standards, clean samples, no matrix effects. So we're going to have a different approach when we look at the blood serum sample.